Today we're talking about approximating logarithms, and then also change of base. If you notice here on this first part, if we are trying to find log base 2 of 10 and we put equals x and we change it to exponential form, we get 2 to the x equals 10. Well, I cannot change 10 to be base 2. So in this case, we would have to approximate the log. What you would do is you would start writing down, okay, I know that 2 to the 3rd power is 8, and I know that 2 to the 4th power is 16. Well, 10 is in between 8 and 16, isn't it? Mm-hmm. So therefore, the answer for x would have to be between 3 and 4.
So you have to do the decimal?
You do not have to do the decimal, but on a multiple choice question, like if you got a test and it had a multiple choice answer, they wouldn't, so your answer would be like 3 point something. You could choose the correct answer knowing that the answer is in between 3 and 4.
Okay.
Does that make sense?
So it won't be like 3.1, 3.5.
No.
Okay.
No. Okay. So on B, let's first change this. If we change this to exponential form equals x, we would change this to 3 to the x equals 25. Okay. So I'm going to just start writing down. 3 to the first is 3, right? 3 to the second is 9. 3 to the third is 27. Well, 25 is in between 9 and 27, right? Therefore, because we're trying to find x is the exponent, my answer is between 2 and 3.
So that's all you put, just put between 2 and 3?
Yep. Okay, so I would like you to try to do examples 1 and 2 right below there. So when you get your answers, you can write them on your whiteboard, or I'll come around and check some of you. But yeah, so I'm going to give you about a minute to try those.
Okay, so it has to be like
81, and then 81 times 3 is 243. And it's
Oh, perfect. No. 4. Good, you got it. I heard your answer. Okay. So the first thing I would do is change this here into exponential form by putting equal x, and then I would write 7 to the x power equals 9. Well, in this case, 7 to the first power is 7, and what is 7 to the second power? 49. And 9 is obviously in between 7 and 49. So my answer for this is between 1 and 2. For the second one, let's go ahead and change that into exponential form. And so when we write this, we get 3 to the x power equals 200. Since 200 is so large, I'm not going to start with the first. So the first is 3, the second is 9. Let's go ahead and go with the third. 3 to the third is 27. 3 to the fourth is 81. 3 to the fifth is
big number.
243. So 200 is in between 81 and 243. So that means my answer is going to be between
4 and 5.
4 and 5.
Yeah.
Okay. Is there anybody that would like to read this paragraph right here for me?
I'll do it.
Thank you, Anthony.
In the above problems, different bases were used, bases 2, 3, and 7. Because calculators have limited buttons and cannot support problems in different possible bases, they have chosen 2 bases, base 10 and base e. Remember, e is a rational number like I, but with approximate value of 2.718. You can convert all logarithm problems to equivalent logarithms with the base 10 or e. Below is the formula to convert logarithms.
Okay. One thing I want to talk about before is, like, remember last night's homework where we were condensing or expanding logs? Mm-hmm. Okay. And, like, if we had a single log on both sides, we could drop the logs, single logs. Okay? There was another thing. And then when we are condensing the logs, you're writing it as a single log when you're condensing it, right? So it starts out at 2, but it's just the natural log, and you're writing x over 5, okay? So it's important to remember because this is a little different. On here, we're having a log divided by a log. Before when we were doing it, it was just a log with the division problem, okay? So what this means is when you want to change a base, if you have log base c of a, we can change this to be 2 logs. C is going to the denominator, and a is going up to the top. Okay? We're going to hold this for just a second.